Snowflake's rise in the tech world really wasn't an accident. It was a full-blown revolution. They didn't just build a better mousetrap, they basically redesigned the entire house. So today, we're going to unpack what Snowflake is, how its pretty unique architecture works, and why it's suddenly at the very center of the whole AI conversation.
So to really get why Snowflake is such a big deal, you first have to understand the problem it was built to solve. For decades, big company data systems were kind of like old landline phones, powerful for their time, but incredibly rigid. If you needed more processing power, even just for a few hours, you had to install a whole new, super expensive system. It was slow, it was costly, and it was a massive bottleneck for any company trying to be agile.
And this is exactly where Snowflake just completely flipped the script. They looked at this rigid, bundled-up world and asked a really simple question. What if you could get all the data processing power you need, exactly when you need it, and this is the key part, pay only for what you actually use? They didn't just tweak the old model, they built a brand new one from the ground up, designed specifically for the cloud. And it made everything fast, flexible, and way more efficient.
Okay, so at its heart, Snowflake is a cloud data platform. The big idea is to have one single place for companies to store all their data, run their analytics, power their apps, and now even build and run their AI models. But the real magic isn't just what it does, it's how it was built.
You'll hear the term cloud native thrown around a lot with Snowflake. And look, it's not just some marketing buzzword, it is everything. See, unlike older systems that were just kind of lifted and shifted into the cloud, Snowflake was designed from day one to take full advantage of the cloud's natural ability to scale up and down. That one decision is the foundation for everything that makes it so powerful.
So let's actually dig into that architecture, because this is where we find the core innovation, the elegant, almost simple secret behind Snowflake's incredible performance and its meteoric rise.
Okay, so think of it like this. Snowflake is built on three totally separate, independent layers. First, you have the storage layer, which is pretty simple. It just holds all the data. Then you have the compute layer, which does all the heavy lifting, all the processing. And on top, you have the cloud services layer, which is basically the brain that manages and coordinates the whole operation. And the most important thing to get here is that these layers can all scale completely independently from one another.
And this right here, this is the big one. This is the single most radical idea in Snowflake's entire design. For something like 30 years, the industry standard was to bundle storage and compute together. They were inseparable. Snowflake said, nope, we're separating them. This one architectural choice changed the entire game for the economics and flexibility of working with data.
So why does this separation matter so much? Okay, imagine your kitchen pantry is your data storage, and your oven is your computing power. In the old world, if you wanted a more powerful oven, you were forced to buy a bigger house with a bigger pantry you didn't need. It just didn't make sense. With Snowflake, you can keep your pantry the same size, but rent a commercial-grade pizza oven for just 1 hour to host a party, and then turn it off when you're done. You only pay for that massive oven power while you're actually using it. That is the game changer.
So this unique architecture, it's not just some cool engineering flex, right? It unlocks a whole set of features that honestly feel like superpowers if you're someone who works with data every day.
First up, there's a feature called time travel. I mean, just imagine this. Someone on your team accidentally deletes a critical data table, literally 1 minute after a huge process finishes. In the old world, that's a 5-alarm fire. You're talking about slow, painful backup restores. With Snowflake, you can literally run a query to see the data as it existed before the mistake happened and instantly restore it. It turns a potential disaster into a complete non-event.
Then you've got zero-copy cloning. Okay, let's say a developer needs a full copy of your multi-terabyte production database to test something new. Traditionally, that's a project that could take days and cost a fortune in storage. With Snowflake, you can create a fully functional, writable clone of that entire database in seconds. And it costs virtually nothing in storage until you start actually making changes. This just massively speeds up innovation. And maybe the most transformative feature of all is secure data sharing. Instead of those slow, risky data transfers using file servers or clunky APIs, you can just grant another company live, governed, read-only access directly to your data. They query it in their own Snowflake account using their own compute, but the data itself never leaves your control. This is the foundation of the Snowflake marketplace and a true paradigm shift in how companies collaborate with data.
All right, so with all these killer features, you've got to wonder, where does Snowflake actually fit in this super competitive cloud data market?
First off, let's just get a sense of the battlefield here. This isn't a small niche.
the cloud data market is a massive, and I mean massive, and rapidly growing universe. We're talking about a projected value of over $43 billion by 2032. This is a big pond, and it is filled with sharks.
So who are the main players? Well, you've got the cloud giants themselves. Amazon's Redshift, which is kind of the default choice if you're all in on the AWS ecosystem, and Google's BigQuery, which is famous for its insane query speed and built-in machine learning. Then you have Databricks, Snowflake's biggest rival, which champions the lakehouse idea, trying to unify data analytics and AI. Snowflake's sweet spot has always been its incredible ease of use and that powerful data sharing, but it has one other major advantage up its sleeve.
And that advantage is this: it's multi-cloud. Snowflake doesn't care if you use Amazon Web Services, Microsoft Azure, or Google Cloud. It just works, consistently, across all of them. This gives companies the ultimate freedom from getting locked into one vendor. They can choose the best cloud for their other apps without having their data held hostage. It's a really powerful strategic move.
So, what's next? Well, Snowflake is not content to just be a data warehouse. Not at all. Their ambition is way, way bigger.
They're moving fast, become what they're calling the AI data cloud. They're adding tools like Snowpark so developers can run their Python code right where the data lives, and Cortex AI, a service to build AI apps without ever having to move your data out of the platform. Basically, they're building a complete operating system for data, where everything from storage to application logic to AI all happens in one unified place.
Now look, it's not all a perfect story. There is a trade-off here. That same pay-for-what-you-use flexibility that makes Snowflake so powerful, well, it means you have to be disciplined. With the ability to spin up massive amounts of computing power with just a single click, costs can absolutely get out of control if you're not paying close attention. Strong governance is key.
And all this brings us to the final and really the most crucial question. Snowflake started by completely revolutionizing the data warehouse, but now it's in an all-out race with giants like Google, Amazon, and Databricks to become the central platform where a company's data gets transformed into actual intelligence. The question isn't just about data anymore. It's about who is going to build the definitive operating system for AI itself.